A closer look at the science and engineering practices. Welcome back. In this session, we're going to take a closer look at the science and engineering practices. The goals are to understand the science and engineering practices, be able to identify the practices and performance expectations, recognize the important role of practices in science. Engaging in the practices of science helps students understand how scientific knowledge develops. This direct involvement gives them an appreciation of the wide ranges of approaches that are used to investigate, model, and explain the world. Engaging in the practices of engineering also helps students understand the work of engineers as well as the links between science and engineering. Participation in these practices also helps students form an understanding of the cross-cutting concepts and disciplinary ideas of science and engineering. Additionally, it makes students' knowledge more meaningful and embeds it more deeply into their worldview. The development process of the standards provides insight into science and engineering practices. These insights are shared in the following guiding principles. Number one, students in grades K through 12 should engage in all 8 practices over 8 grade bands. Students' abilities to use the practices grow over time. However, the NGSS only identifies the capabilities students are expected to acquire by the end of each grade band. Number two, practices grow in complexity and sophistication across the grades. The framework suggests how students' abilities to use each of the practices should progress as they mature and engage in science learning. Number three, each practice may reflect science or engineering. Each of the 8 practices can be used in scientific inquiry or engineering design. The best way to ensure a practice is being used for science or engineering is to ask about the goal of the activity. Is the goal to answer a question? If so, students are doing science. Is the purpose to define and solve a problem? If so, students are doing engineering. Number 4, practices represent what students are expected to do and are not teaching methods or curriculum. The framework occasionally offers suggestions for instruction, like how a science unit might begin with a scientific investigation, which then leads to the solution of an engineering problem. The NGSS avoids those suggestions since the goal is to describe what students should be able to do rather than how they should be taught. Number 5, the 8 practices are not separate. They intentionally overlap and interconnect. The 8 practices do not operate alone. They occur sequentially and even overlap. For example, the practice of asking questions may lead to practice of modeling or planning and carrying out an investigation, which may lead to analyzing and interpreting data. The practice of mathematical and computational thinking may include some aspects of analyzing and interpreting data. Just as it is important for students to carry out each of the individual practices, it is important for them to see the connections among the 8 practices. Number 6. Performance expectations focus on some, but not all capabilities associated with a practice. As the performance expectations were developed, it became clear that it's too much to expect each performance to reflect all the components of a given practice. The most appropriate aspect of the practice is identified for each performance expectation. Number 7, engagement in practices is language intensive and requires students to participate in classroom science discourse. The practices offer rich opportunities and demands for language learning while advancing science learning for all students. English language learners, students with disabilities that involve language processing, students with limited literacy development, and students who are speakers of social or regional varieties of English gain much from the science learning that involves language-intensive scientific and engineering practices. When supported appropriately, these students are capable of learning science through their emerging language and comprehending and carrying out sophisticated language functions using less than perfect English. By engaging in these practices, they also build on their understanding of science and their language proficiency. Let's take a look at the 8 science and engineering practices. They are number 1, asking questions and defining problems. Number 2, developing and using models. Number 3, planning and carrying out investigations. Number 4, analyzing and interpreting data. Number 5, using mathematics and computational thinking. Number 6, constructing explanations and designing solutions. Number 7, engaging in argument from evidence. Number 8, obtaining, evaluating, and communicating information.